Brace yourself, Yugi. You've never
Bro, look at that, bro. He's so sick.
You can't beat him.
That's crazy. Yes.
Well, what do you think you're doing?
I'm just taking the pepperoni piece.
Yeah, that was my pepperoni though.
It's in the box. It doesn't belong to anyone.
Bro, if it was more on mine, then it's mine.
Listen, it's in the box. It's a
It
free-for-all.
was 60% on mine, 40% on yours.
Then why didn't you grab it? Then why didn't you grab
You're
it?
stealing it from me.
doesn't
You're
belong to
stealing.
This is why she left you.
If it's my pepperoni, it's mine. I'm gonna take it.
It's mine. Listen, it's mine.
Well, no, it's not.
mine. It's
Look,
mine.
if it's mine.
Why are you being like a...
This is what we call a global common. Global commons are essentially the Earth's unknown natural resources. Today we're going to be talking about freshwater as a global common and the influence of game theory on freshwater resource politics, specifically in response to climate change. Currently, there are two paradoxical ways in which freshwater as a global common is being transformed. The first is through increased scarcity due to changes in precipitation and flow patterns, as well as the increased frequency of droughts and evapotranspiration. The second is through increased availability due to increased melt rates of icebergs and glaciers in polar regions. But what is game theory, and how does it influence freshwater politics? Game theory is essentially a theoretical framework concerned with analyzing the interactions of epistemic agents in a situation where the participants' outcomes is critically dependent on the actions of the other agents in the group. Essentially, it's a big game of socio-ecological chicken. As freshwater becomes an increasingly important resource, nations will have to choose between competition or cooperation to secure ownership rights over freshwater resources. In competitive game theory, each agent makes decisions that unilaterally benefits them the most. The goal is to reach what we call a Nash equilibrium, where the agent makes choices that leaves them better off no matter what the other agents in the group decide to do. In cooperative game theory, on the other hand, agents try to determine what is fair by establishing what each agent is entitled to based on the shared costs or responsibilities. This is what we know as a Shapley value. So let's look at an example. Say Canada wants to address freshwater insecurity in Indigenous communities. Competitive game theory suggests that Canada should harvest as many glaciers and icebergs as possible to secure those freshwater resources before any of the other agents can do so. Whereas cooperative game theory dictates that Canada should work with neighboring countries in the Arctic Circle to determine a fair way to divide freshwater ownership among the different agents. Competitive game theory tells you to be smart. Cooperative game theory tells you to be fair. But as the impacts of climate change continue to intensify, and the situation becomes much more dire, the question that lingers now is, which game are we going to play?